Okay. Hi everyone. Assalamualaikum. Okay. Today I would like to share another one type of displacement transducer. It is strain gauge. Okay. Before this, we already discussed about the potentiometer. Okay. Potentiometer. Do you still remember? Potentiometer is electromechanical device containing a resistor that is contacted by a move slider, right? Motion of the slider result in a resistance change. Okay, so meaning from the potentiometer, okay, so we can get the output is a voltage, and then how to calculate how to calculate the output from the potentiometer. We use the VDR, meaning we use voltage divider rules. Okay, when you want to calculate the output voltage from the potentiometer, right? Okay, so for today we will cover another one type of the displacement transducer. Is strain gauge. Okay, strain gauge is one of the passive transducer. Okay, what is a passive transducer? What is a passive transducer? Passive transducer, this is require external power source for energy conversion. Okay, so instead of strain gauge, we have RTD also. This is one of the passive transducer, and the photoresistor also is a passive transducer. Okay, now we want to discuss about strain gauge. Okay, you heard before about the strain gauge? Okay, what is the strain gauge actually? What is strain gauge? What is strain gauge? Strain gauge is a metal or semiconductor element whose resistance change when under strain. Okay, and what is a strain? Strain is the result of the application of force to solid object. Example, we apply the distortion. Okay, meaning we apply certain force to the solid object, so the result is a distortion. Okay, meaning there will be effect chain of dimension or deformation, right? Okay, that's a strain. How about the stress? Stress is the force that apply to the object. Okay, that's a stress. That's what is the definition about stress and strain. Okay, and now we want to see the relationship between the stress and strain. Okay, so we can divide the stress and strain relationship into two. One is a tensile, okay, tensile stress strain, right? And the second one is a compression stress strain. Okay, what's the difference between both tensile and compress? Okay, tensile force is when we what I want to say, tensile force apply to a sample of material. Okay, we apply to the strain gauge, right? So to elongate or pull apart the sample. Okay, when we apply tensile, when tensile force apply, okay, so the material will be elongate or pull apart our sample. So the equation we can derive from the tensile stress is force over area. Okay, F is the applied force, and then there will be effect the cross-sectional area. Okay, this is a tensile stress. And then what is the tensile strain? Okay, strain is what is a strain? Just now, what is a strain? Strain is when uh, what is a chain of dimension. Okay, this is a strain, right? Okay, so the equation for the tensile strain is there will be effect the original length. Okay, will be effect with the original length. So you can see from the this one. Okay, from this figure, this one about the strain. Just now we're talking about the stress. Okay, we have a two tensile and compression. Okay, just now we talking about the tensile strain. Okay, tensile strain meaning L. Okay, this one L is the original before we apply certain force. Okay, when we meanings L is the original unstressed length, right? When we apply force, there will be effect to the length. So that's a come up with the we can label with delta L, right? So that's we can derive the strain is equal to delta L. Delta L is a change in length over L. L is the original unstressed length. Okay, that's a strain. Okay, another one another one is a compression. Meaning we compress the material. Okay, tensile force press on the sample of material. So they also we can calculate the compression stress. Another one is compression strain. Okay, the formula also same. Stress is a force over A, and then the strain is delta L over L. Okay, so you can see from our extra note. Okay, from figure 2.15. From there, you can see the figure tensile and compression stress. Okay, they apply to a rod, right? So figure 2.15a is a tensile stress applied to a rod, right? And then with there will be show they apply force, and then there will be effect with the length and the cross-sectional area. In figure B, 2.15b is when compressional stress applied to the rod. Okay, that's from the extra note, figure 2.15. Okay, right, now we come back to this slide. Okay, okay, actually the strain gauge is metal or transducer whose the resistance will change when the material or when the transducer is under strain. Okay, this one. When we apply strain, the resistance change. Okay, so we can derive we can write this equation. R is the resistance equal to resistivity time with L and over cross-sectional area is labeled with A, right? Okay, now from This is okay. So what is Young modulus, or we label with E? Young modulus is the constant proportionality between stress and strain. Okay, the constant proportionality between stress and strain for a linear stress strain curve. Okay, this is considered a relationship between stress and strain curve. So known as, or we label as or we call as a Young modulus. Okay, and the label is E. E equal to stress over strain, right? Okay, now the next slide, I want to share what is the relationship between input and output of a strain gauge. Okay, so we can express the relationship between input and output of the strain gauge by the gauge factor. Okay, by the gauge factor. This one. Okay, gauge factor is a delta R. Delta R meaning change in resistance when we apply strain, and then over R. As R is the original resistance before we apply strain, right? And over sigma. What is a sigma? Sigma is strain, right? Okay. Okay. Can you see the bridge below? Okay. Strain gauge is used to send the strain produced by a force on the wire. Strain gauge is generally used an arm of a bridge. Okay, so you can see from the bridge. Okay, you can see from the bridge figure there. So one of the arm is we replace with a strain gauge. Okay, right? So hopefully everybody can follow our discussion on the strain gauge. Now, let's try the first uh, example. Okay, okay. So, example one, a strain gauge is used to measure force in lab. Okay, and multimeter is used to detect the change in resistance. Okay, and then what's the parameter is given? They give a gauge factor. Gauge factor is for uh, the gauge resistance 200 ohm, and the strain on the gauge is 2 times 10 to minus of 5. Okay, you have to calculate the expected change in resistance measured by the multimeter. So meaning calculate, oops, sorry, you have to calculate the expected change in resistance. So meaning you have to calculate what is the delta R. Okay, what is the delta R? So meaning R is given. What is the original R? Original R is about 200 ohm, right? And then the strain also is given. What is the strain? Strain is a sigma equal to delta L over L, right? Okay. So, and how to calculate the delta R? So, how to calculate the delta R is you can use this equation to calculate the delta R. Okay, gauge factor is given. Okay, gauge factor is given for Okay. Okay, they give a gauge vector. This is given, and then this is also given, are also given, and then the string also is given. Okay, now from there you can calculate your expected change in resistance when we apply uh, what when we use our strain gauge to measure force. When we apply force, okay, and then they have change in resistance, right? Okay, let's try this example one, and then what's the value of delta R based on the information given. Okay, let's try example one first. Okay, thank you. We will continue for the next videos.